In this video, we will be solving a relatively simple project crashing problem. As you can see, there are 3 routes through the network. And I think on a problem of this size, the easiest way is to make a list of them. We can go A to B to E. We can come straight across A to C to E, or we can go A to D to E. And then for each of those paths, I like to write the amount of time that it takes. Going from A to B to E takes 19 days. A to C to E takes 18, and A to D to E takes 17. So that's where we've started. And then I find it helpful to sort of, it's supposed to be red, underline or something the critical path. And then it's also helpful if you do something to help yourself out by notating on the drawing the critical path. So we have that. And then if we're going to crash it, speed it up one day, we want to find the cheapest way to do that. And obviously we have to crash either A or B or E. Crashing the other things, they're not critical, so it won't get the project done faster. So A is $180. B is $100, E is $300, so clearly the cheapest of those 3 is B. So anything with the B will now be one day faster. And there's only one path that goes through B, that's the critical one. So that will be one day faster, and it's now 18 days. A to C to E doesn't have a B in it, so it's unaffected and it stays 18 days. A to E also unaffected, stays at 18 days. So if we look at the longest paths through our network now, A to B to E is still got the greatest length, but it also matches A to C to E. So this path is critical now. As far as housekeeping, it might be helpful to make a little note here. Okay, we could crash B one more time if we wanted to, B did take 10 days, but now it's down to 9. Alright, so if we wanted to crash it another day, we could crash A. So we have to crash things that are on both paths now. We have to speed up both of these critical paths. And A is $180, and E is $300. And crashing B by itself does me no good. Crashing C by itself does me no good, but if I crash both of them, then I'll speed up both critical paths. B is $100, C is $50, and that's the cheapest of the options that I just looked at. So that is what I will do. I will crash B and C, and anything with the B or C on it is now one day faster. So the 19 days goes down to 17, sorry, 18 days goes down to 17, and this 18-day time goes down to 17. But ADE, it doesn't have a B or a C on it, so it just stays what it is, which is 17. And now everything takes 17 days, so now everything is critical. So if we want to speed things up, we have to crash things on all the critical paths now. But back to the housekeeping. B could be crashed twice, and we've crashed it twice, so no longer an option. C could only be crashed once, so no longer an option. If we want to speed things up further now, we can't look at B and we can't look at C. Oh, yes, I should update my drawing here and say this is critical and D is critical and this is critical. And then if you want to update the numbers, you don't have to, but if it's helpful. B's been crashed twice and is down to 8 days. C was crashed once and is also down to 8 days. So we either crash, we could crash D, but crashing D by itself would speed up this path, get it down to 16 days, but these 2 paths would stay at 17, so the project would still take 17 days to do, so we would not have accomplished anything. So crashing D there's no reason to do it. So we crash A or we crash E. A is 180, E is 300, so A is the cheaper one there, so we will crash A, and now anything with an A will be one day faster. And these all have an A, so they will all be one day faster now. And A is down to 3 days, And we could only crash it once, so that's all she wrote there. So the only option left now is to crash E. So we can crash E because it is on all 3 paths. And they all have an E, so they will all be reduced by 1 day. E could be crashed 3 times. Now we're down to 2. It was a 5, and so now it's 4. We could do it again. It worked the first time. Let's do it again. The critical paths did not change, so it worked before. Let's do it again. E could be crashed 1 more time if we wanted to. This is down to 3 now. But yeah, let's do it 1 more time. So these 14s now all become 13s, and that is the fastest that we could do the project. So the fastest we could possibly do this project is 13 days. I guess and update that if anybody cares about that, and he's all done. And in order to accomplish that, we would crash B 2 times, and C once, and A once, and A 3 times. Okay, so if the goal is just to try to figure out the fastest we could possibly do this, well, there's our answer, 13 days by crashing B twice, C once, A once, and E 3 times. Now let's talk about costs. If we crashed B by itself, that would cost us $100. If we crashed B and C together, that is $150. Crashing A by itself, $180. Crashing E is $300 each time we did it. So if the benefit per day from speeding this up was, say, $500 a day, it would make sense to do all these things because every one of these things is less than $500. If the benefit per day is only, say, $200, then we should just stop right there and speed the project up by 3 days. I have to be careful now because I'm trying to draw brackets and I'm not good at that. So speeding it up those 3 days would cost us 100 plus 150 plus 180, which is $430. So let's go with that as an example. If the benefit per day is $200, then what we want to do is we want to crash it only 3 days. So the benefit we would get from that is 3 days times $200 a piece, which is obviously $600 of additional revenue. And let's look at the costs now. If you already did this and added that up and knew that it was $430, cool. That's all we're trying to figure out. If you hadn't already done that, how many times we crashed B twice at a cost of, let me see, write it the other way here. So for B, it'll be 2 times $100. So that would be a cost of $200. For crashing C, it's just $50 because we only did it once. And then crashing A, it would be $180 because that's the cost of crashing A. And if you add those all up, you get $430. So the amount that our profits go up by, let's call that increased profits of 600 minus 430. So we would have increased profits of $170. So we'd make an additional $170 by crashing B twice, C once, and A once. So let's recap what we did here. So the first thing that we did is we found the critical path. So that's the first thing we want to do. And then the next thing that we did was find the, get myself a little in there. So was to identify the cheapest crash. So we did that. So we identified what the cheapest activity or activities to crash would be. And then the third thing was we actually crashed those activities. And then we checked on the critical path to see if the critical path had changed. So we just went back up here to the top and we did it again. And we kept doing it until, depending on how we're looking at it, so repeat it until we have, I'm sorry about my writing here. We either have no more crashing possible, like when we did it at the start, we're just trying to see how much is possible, or if we had, say, already known that the profit per day was $200, there would have been no reason to do this other stuff here. I mean, once we'd realized that we couldn't get any more crashing done for less than $200, it's time to stop. So we repeat it until either there's no more possible or there's no more crashing that is economical. And that's what we just did.